Hello friends, in my last video I have discussed about the CB configuration, that is count based configuration, and its circuit, and I have discussed a relation that is IE equals IB plus IC. I have discussed the introduction to the transistor, introduction to the NPN BJT transistor. So today we are going to discuss about the input characteristic, output characteristic, and lots of things, new things about the CB configuration of the transistor. So input characteristic. What is the input characteristic of the transistor? Input characteristic of the transistor means whenever we are going to draw IE, that is emitter current, and VBE, that is base to emitter voltage, whenever we draw the variation of VBE with IE, this graph. So this is input characteristic. So after a certain cut-in voltage, the graph will be like that, such as here VBC is constant. That means what do we mean by input characteristic of the CB configuration? By input characteristic of the CB configuration, we mean that whenever we will draw the variation of input emitter current with respect to VBE, then we will get some characteristic curve here, and the curve will originate after a certain cut-in voltage, keeping VBC constant. Then we will get such curve. This is the input characteristic of the CB configuration. And what will be the output characteristic? Output characteristic of the CB configuration is such that we will draw here IC and VBC. Here IC versus VBC. And here IE, that is emitter current, will be constant. And graph will be like that. After that, graph will be constant. Up to this, the graph will rise, and after that the graph will be constant. Let me rise properly. Here the graph will rise, then after that the graph will be constant. Here IE is emitter current, will be constant, and here VC cut-in voltage. So this is the output characteristic of the CB configuration. So what we get, that in case of input characteristic, we will get IE, that is variation of emitter current with respect to base to emitter voltage, and in case of output characteristic, we will get variation of collector current, variation of IC with respect to base to collector voltage, and there IE, that is emitter current, will be constant. So these are the input and input characteristic and output characteristic of the CB configuration. Now in case of common based configuration, we will get a relation. What is that relation? The relation between collector current and the leakage current. Collector current IC is given by IC majority plus ICO. So here IC is collector current, and for collector current here it is a majority carrier. IC, this current is due to the majority carrier, and this ICO is the leakage current. This ICO will be the leakage current. Leakage current is what? See, whenever you are writing IC, you are writing IC majority. That means collector current due to the majority carrier. And here it is ICO, that is leakage current, that is collector current due to the minority carrier. That is minority carrier. So these are the things that we will define IC, by which we will define IC. Here you have to memorize another thing. You have to know another important fact, that is current gain. What is current gain in CV configuration? Current gain in CV configuration. Current gain in CV configuration, there is a relation, that is alpha DC equals IC by IE, that is collector current divided by emitter current. And here you have to know important fact, that here collector current less than IE. That means what? Here IC, that is collector current, will be less than emitter current, and so what? That means alpha will be less than 1. So we can write what? We can write here one thing, one important thing we can write, that is IC equals what? IC equals, we know, IC majority plus ICO. IC majority plus ICO. And now IC equals what we know? Alpha E plus ICO. Alpha E, you know. Now this is the relation between collector current and emitter current in CB configuration with ICO. This leakage current, this is alpha E, and this is collector current. Alpha E, alpha is current gain, and IE is emitter current. Now if you do emitter current equals 0, that is IC equals ICO. That means whenever you will do emitter current is 0, emitter current when will be 0, then total IC, total collector current will be due to the minority carrier, and that current will be ICO, that is a current due to the minority carrier, and that will be leakage current. That means if emitter is, that means we can write one thing, IE 0 means if emitter is open. If emitter is open, then we can write current flowing through the collector, current flowing through the collector is 0. We can define it through circuit diagram also. Here it is emitter, here it is collector, and here it is base, and here it is open, and here it is like that. So here emitter portion is open, so current through the collector is 0. So that's a little thing about CV configuration. In my next video I will discuss about CE common emitter configuration, and lots of videos will come about transistors. So thanks for the time being. Thank you so much for patiently watching. Bye.